Hey everyone, welcome back to my channel. Today we'll be talking about differentiation.
Differentiation. It is a process where we find instantaneous rate of change in function based on one of its variables. For instance, velocity is rate of change of displacement with respect to time. So, v equals to ds upon dt, where s is displacement and t is time. If x is a variable, y is another variable, then rate of change of x with respect to y is defined as f dash of x equals to dy upon dx. F dash of x equals to derivative of a function. Differentiation is used to calculate highest and lowest point of a curve or, or even tangent and normal to a curve if fx undergoes a small change h near x. Then derivative is limit h tends to 0 fx plus h minus fx upon h, provided the limit should exist.
Let's take an example. Here our fx is 5x. So we have to find the derivative at x equals to 2. So f dash x is f of x plus h minus f of x divided by h, where limit h tends to 0. So f of 2 plus h minus f of 2 divided by h. So it will give you the value as 5 because h and h will get cancelled. You can write derivative as f dash x, which is a Lagrange's notion, or dy by dx, which is Leibniz notion, and d bracket y, which is Euler's notion. Anything is fine. Now let's look at some of the differentiation formulas. If f of x is tan x, then f dash x is sec square x. If f of x is cos x, then f dash x is minus sin x. If f of x is sin x, then f dash x is cos x. Just see the differences between these two. If f of x is ln x or log x, f dash x is 1 by x. If f of x is e to the power x, f dash x is e to the power x. Same. If f of x is x to the power n, where n is any integer, then f dash x is n x to the power n minus 1. Let's take an example, x cube. So if you differentiate it, it will be 3x to the power 3 minus 1, which is 3x square. Now, if fx is equal to k, where k is a constant, f dash x will be 0. If fx is equal to cot x, f dash x is minus cosec square x. If f of x is sec x, f dash x is sec x into tan x. If f of x is cosec x, then f dash x is minus cosec x into cot x. If f of x is a to the power x, where a is any integer, then f dash x is a to the power x into ln a. Below is an example. If f of x is log x at the base a, then f dash x is 1 by x log a. Now, there are certain rules of differentiation. Let's look at them. First is sum and difference rule. So if f of x is ux plus minus vx, then if we differentiate it, it will be u dash x plus minus v dash x. Product rule. If f of x is ux into vx, f dash x will be u dash x into vx plus v dash x into ux. Quotient rule. If f of x is ux by vx, then f dash x will be u dash x into vx minus v dash x into ux divided by vx square. Now chain rule. Suppose y is a function of x and that is a function of u, and u is a function of x again. So the chain rule states dy by dx will be dy by du, because x is a function of u, and then u again is a function of x, so it will be du by dx. Let's solve some questions to get a more clear understanding on differentiation. Differentiate fx is equal to 3x to the power 6 minus 8x plus 2 with respect to x. So, using the formula n x to the power n minus 1 for the first one and for the second one also. So, x to the power 0 is nothing but 1, and the third term 2 is a constant, so the differentiation will be 0. So the value is 18x to the power 5 minus 8. Next, differentiate y is equal to x bracket 3x cube minus 8. Simplify the expression, you will get 3x to the power 4 minus 8x. Now put the formula n x to the power n minus 1. So the equation becomes 12x cube minus 8. Next is 3 sin x plus cos x minus tan x. You know the differentiation of sin x will be cos x will be minus sin x, and tan x will be sec square x. Next is x cube sin 2x. Clearly observe this is in a product form. So x cube will be ux and sin 2x will be vx. So differentiate this. First we differentiate x cube. So it will be 3x square and keeping sin 2x same. Then in the second part we differentiate sin 2x. So sin 2x will be differentiated with respect to 2x, and then 2x will be differentiated with respect to x. So first term will give you cos 2x and 2 will be the second term. So the solution will be 3x square sin 2x plus 2x cube cos 2x. So here we followed product rule and chain rule. Next question, 4x e to the power 2x minus 9x. So clearly observe the first term, this is also in a product rule form. So first we differentiate x, it will give you 4 e to the power 2x, and in the second part we have to differentiate e to the power 2x. So differentiate e to the power 2x with respect to 2x, and then again differentiate 2x with respect to x. Chain rule and product rule in this case. So the solution will be 4 e to the power 2x plus 8x e to the power 2x minus 9. Next question, if fx is x divided by x minus 2, find the derivative using the limit definition. So f dash x will be f of x plus h minus fx divided by h, where limit h tends to 0. So put the values of x plus h in the equation. So you will get, now simplify this cross multiplication. Cancel the terms. So you have minus 2h divided by x minus 2 divided x plus h minus 2 and h. So h and h will get cancelled, and put the value of h as 0 because h was tending to 0. So what do you get? Minus 2 x minus 2 whole square. Now you have to solve this using the quotient rule. Quotient rule states that if f of x is ux by vx, f dash x will be u dash x vx minus v dash x ux divided by vx square. So first differentiate the x differentiation will be 1, then put vx which is x minus 2, then again differentiate vx. So x minus 2 if you differentiate it will only give 1 because the second term which is minus 2 is a constant, it will be 0. Now again put ux which is x, so divided by vx which is x minus 2 whole square. So clearly observe the solution is same in both the cases. But I think differentiation was better. Next, let's look at some of the formulas, differentiation formulas for inverse trigonometric functions. We'll be discussing some examples in our next video. For now, just keep this handy and try to remember this. These are the basic formulas. So if fx is equal to sine inverse x, f dash x will be 1 by root under 1 minus x square. If fx is equal to cos inverse x, f dash x will be minus 1 by root under 1 minus x square. Can you see the differences in sign for these two? Yeah, same happened in differentiation also of sin x and cos x. Next, fx is tan inverse x. So f dash x is 1 by 1 plus x square. Fx if is cot inverse x, f dash x will be minus 1 by 1 plus x square. Again see the opposite sign. If fx is sec inverse x, f dash x is 1 by mod x root under x square minus 1. Similarly, if fx is cosec inverse x, f dash x is minus 1 by modulus of x root under x square minus 1. Again change in sign. So just remember one and make the sign reversal in the next case. So it will be easy to remember. If you like the video, please like, share and subscribe. Thank you.